All right, facts, frequently asked questions. So, how much capacity greater than the maximum load is ideal? Well, it depends. A lot of these, that'll be the answer. But certainly want to know what the maximum load is that wants to be lifted. We also have to consider what might happen if, say, a load shifts or something happens that isn't expected. And then you also have a safety factor. So it could be that whatever the maximum possible load is, including, say, overload or something going wrong, you have to have maybe a safety factor on top of that of up to 5 times for safety purposes, for example. So it's very much application specific, and many times you might need quite a bit more safety factor or capacity in the load cell than you might expect to allow for the required safety factors. Number 2, can vibration impact the output of the sensor? Absolutely. Vibration, imagine I have a display that's fast acting and the vibration is causing the load to change. That'll cause your display to roll around, might even be such that it's difficult to read. So how can you mitigate that? Filtering, for example, if you have relatively high sample rate, you might have a display that filters that out so it reads steadily. You also might be monitoring that with the data acquisition system that is actually reading the higher speed data so you can see these vibrations. If you have impacts or things that could affect the life or the safety factor of the sensor, you'd want to necessarily know what those are, not filter them out. But yeah, vibration can cause issues with reading a display, certainly. What are the key considerations when mounting a sensor used for lifting? Well, one is definitely the attachment points to the device being listed, and also the sensor and any things in line with the sensor, like clevises, rod-end bearings. Everything has to be rated for not only the load being lifted, but any safety factors that are required. Also, load cells and sensors have a load axis. It's important that fixturing and things allow the load to be aligned with the load axis. So you imagine if, say, a load cell is, say, hard mounted, and then you have a sling or something attached that's coming off at an angle, that won't work very well. It's creating a lot of bending loads into the load cell. It's not going to measure accurately. So again, you maybe want a rod end clevis on each end of it, for example, so that they can self-align. Obviously, then something like a load shackle or a tension link kind of has that feature built in where it wants to self-align. Number 4, can you set alarms if the force sensor readings exceed a certain threshold? Absolutely. A lot of devices, instrumentation used in lifting have that feature as a standard feature where you can set thresholds, and if the load exceeds a certain threshold, you might get an alarm. If it exceeds another threshold, you might get a louder alarm or a shutdown trigger. So absolutely. What instrumentation is best for analyzing performance data during lifting process? Well, typically you want instrumentation that allows logging of the data, and you might want a relatively higher sample rate than if you're just visually displaying the load. And that's so you could say look at it afterwards and see what happened. Again, if say something drops, you may not even see it happening on a display, but if you were monitoring the load in real time with a relatively fast data collection, you might see these spikes. And if you have a safety factor and the spike exceeds that, well, you need to take that part out of service, and it may be completely compromised if this load exceeded a certain level, and you wouldn't necessarily know it if you weren't analyzing that data, say in the high-speed instrument. What are the limitations of using wireless sensors and instrumentation for lifting? Certainly line of sight and distance. They can transmit up to 500 or 600 meters line of sight. If you don't have line of sight, it drops dramatically. You can potentially transmit, like say, from one building to another. It may or may not work. A site survey can tell you that. If it doesn't, there's things, remote antennas and repeaters and things can be added to a system. But definitely, there's also a limitation of data rate. If you want like very high data speeds, you want a lot of load points, wireless may not be the answer. So definitely application specific. Number 7, if you embed a sensor into a lifting machine, how do you recommend calibrating it? Well, it depends, but in most cases, calibrating the entire system makes the most sense. It's the most accurate and takes into account all of the components in the system, Whereas if you just say calibrate a load cell by itself, you're not really sure how it interacts with the rest of the components in the system. So ideally, a lifting device, you'd lift something of a known weight, and that would tell you if it's operating correctly, and then you can actually use that known weight to adjust and calibrate the instrumentation. Are there limits for environmental conditions? Absolutely. Extreme cold, extreme heat, moisture, all of those things are extremely damaging to sensors and systems that aren't rated for them. So it's important. It's not just an afterthought. What is the environment? Is it in a steel mill? It's going to be lifting a vat of molten steel. Well, that's important to know. Is it outside? Is it going to get rained on? Is it on a ship deck? Is it submerged below the ocean? Or is it freshwater or saltwater? How deep is it going to be? All those things can be handled, but you need to know it going in, right? You don't just take a standard load cell or load pin and put it in a shackle down in the ocean without rating it for that. What is the ideal accuracy rating of a sensor for lifting? It depends. A lot of lifting, it's maybe not as important for super precise accuracy. If you're weighing something or lift, it might be. Or if, say, you're handling something that's extremely critical that the lift, and say you're fitting pieces together, you don't want to press them together or allow the weight of the system to press the parts together with too much force, it might be extremely important to measure for accuracy. It really depends on the application. But for lifting and rigging, it's usually accuracy isn't the driving factor. It's more, monitoring and making sure things are being done safely. Why would you choose a load shackle over tension link for lifting application? Well, as Ken talked about, you've got like our low profile load cells. They have threaded holes. They don't necessarily lend themselves to lifting without adding extra items, shackles, clevises, whatnot. Something like a tension link has holes in the end. You can actually put shackles in those holes, or you can, put slings through the holes. So they're a little easier to implement into, say, existing lifting equipment. And then something like a shackle is maybe the easiest, right? Most lifting devices might have hooks or, loops or things that you intend to loop through something. Well, the shackle is an ideal thing to do that with. And if you have a shackle that measures load, it's quite easy to fit that into an existing system. Or systems already have shackles, you just replace the shackles with load monitoring shackles. And that's it for the facts.
That's a great question, questions and answers, Keith. We had one come in that said, when you replace a pin for a load pin, replace the pin with a load pin. Do you need to get that approved or notify the body of who's regulating the equipment?
Well, I would say in some cases, yes, in some cases, no. A lot of times we were working with, say, manufacturers, so crane manufacturers, somebody, they're going to handle that themselves. If it's an end user, it depends what regulations they're required to adhere to. But in very many cases, yes, the answer would be yes.
And our partner has the ability to do many different certifications on the pins. Of course, that comes with a price, but if it is a requirement, as long as it's conveyed to us, we can get that quoted and included in the price of the pin.
Yeah, that's right. Yeah, Ken brings up a good point. Things like Sharpie, rupture testing, and various things that are related to safety and lifting, those can be performed on the actual product and the certification provided with the product.
Got another great question. The specifications of the tension link load cells show that its operating range is -4 to +158. Can the custom version go below -4 degrees Fahrenheit?
I would say yes. I know for sure in a shackle, it's been done. So, using the same manufacturing techniques and gauges and etc., it could be done, but for sure we could do something like that in a shackle because we've done it before. They're moving around, towing around vehicles in Alaska, and sent us some pretty cool pictures, dragging them across the ice.
That sounds fantastic. If there's any other questions, be sure to use the chat feature we'll certainly get those, as well as our application engineers are available to address your specific application needs. As detailed in this presentation, there's a lot of considerations that need to be made based on your environment, the type of use, the equipment, whether you're retrofitting or whether you're using it as a standalone. And it applies to all kinds of industries. You saw rigging of large craft that is going into a test environment or moving big loads or in a warehouse. So lots of great opportunities to utilize different types of sensors to get the best